So here's the heptane molecule. Okay, so what I want you to do, what I want you to think about is, this time instead of to recognize if two molecules are isomers of each other, I would like for you to draw all the structural isomers of C7H16. Now you begin with this one, which is a straight chain. Well, I put it here already, heptane molecule. Okay, can you perhaps draw another molecule with only 6 carbon in the chain? Where you're going to put the 7th carbon? Of course, if you put it here, these two are not isomers, not structural isomers. So why don't you put it here? Okay, this molecule is a hexane because the longest carbon chain, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. The longest carbon chain, it doesn't matter how you count it. There will be 6 carbons, so it's hexane. And there's a methyl branch, so it's a methyl-hexane. And these two are obviously two different compounds, and they are isomers because they both have the same number of carbon and hydrogen. This is also C7H16, but it's methyl-hexane. Now you may want to learn how to count the carbons, because if you count from left to right, the numbering will be different from right to left. In fact, the rule said that to get to a branch, it has to be using the lowest possible number. So therefore it is wrong if I put 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 like this. That's the wrong numbering, because that would be 1, 2, 3, 4, 5. This would be, the methyl would be connected to carbon number 5, but the correct numbering system should always get to the methyl branch using the lowest possible number. So 1, 2, 3, 4, 5. So this is actually a 2-methyl-hexane molecule. So it would be wrong, actually, if you put 5-methyl-hexane, because it's confusing. So it has to be 2-methyl-hexane, not 2 or 5. It has to be 2-methyl-hexane. So what I would like for you to do is to try to draw the other isomers. Okay, in fact, I don't know how many more there are. I drew 2 of them. There may be another 3 or 4 or 5. I just don't remember. But it is something you can certainly look up on the internet and verify your answer. How many possible structural isomers are there based on the chemical formula C7H16? How many possible structural isomers? Okay, this is structural isomers. What I like to do is to quickly talk about, let me try to remember, positional, I think. Okay, so you understand structural isomers. What about positional isomers? Well, it's kind of like structural, except that, for example, you know this? It's called benzene. Okay, so let's say I'm going to have a chlorine here, and then another chlorine here. So that would make it a dichlorobenzene. Okay, well, what about this? Here is another benzene molecule. I'm going to put the chlorine here and here. Now you may ask, okay, what about these positions? Okay, the chemical formula is not C6H6. C6H6 would be benzene. So if you replace 2 of the hydrogens with chlorine, the chemical formula becomes C6H4Cl2. So these are actually positions for hydrogens. But like I said, we're not going to draw the hydrogen because we understand where they are without even drawing them explicitly. This is C6H4Cl2, so is this. So what's the difference between these two molecules? Well, they're positional isomers because the position of chlorine are different. So basically the two are structurally very, very similar, except that the position of the chlorines are different. So what we like to call this one is, well, we're going to start numbering the carbon here. And I'm not going to go number 2. Remember, I want to go to a branch using the smallest number. So if this is carbon number 1, this has to be carbon number 2. And here's number 3, number 4, number 5, number 6. Okay? So this one here, again, you can start here. It doesn't matter. I'm not going to put the 2 here because it will be 2, 3, 4, 5. So I'm going to put 2 here, 3, 4, 5, 6. This molecule, therefore, is 1, 2 dichlorobenzene. 1, 2. Does it make sense? It's 1, 2 because the chlorines, the 2 chlorine atoms, are bonded to carbon number 1 and number 2. This one here, the chlorines are bonded to carbon number 1 and number 3, so it is 1, 3 dichlorobenzene. And these two are positional isomers. Do you call them structural isomers? No, because they are better examples. So, can I draw another one? Can I draw another dichlorobenzene? The answer is yes, because if I draw the benzene, of course, I can have the chlorines opposite of each other. In this case, this is 1, 2, this is 1, 3, this is 1, 4. Now you may ask, can I have a 1, 5? Okay, well, let's try. Here's the benzene. Okay, here's the number 1, 2, 3, 4, 5. Is this 1, 5? Of course not. This molecule and this molecule are identical. You see, if you pick this up, flip it over, these two are identical molecules. In fact, this is carbon number 1, 2, 3, 4, 5, 6. So this is also 1, 3 dichlorobenzene. And therefore, there are only 3 positional isomers of dichlorobenzene. Now, I'm not going to go any further on positional isomers because I want to show you another kind of isomers, and they are functional. Okay, now you have to help me out here. What do we mean by functional isomerism? Well, hopefully you remember the meaning of functional groups. Okay, has something to do with, the organic molecules and how functional groups will give the molecule a certain property. So for example, if you have alcohols, well, this is an alcohol. This is also an alcohol. And I know they're alcohols because of the hydroxyl functional group. Hydroxyl right here and right here. So they're both alcohols, and I know they're going to have very similar chemical and physical properties. Okay, so what are functional isomers? What are functional isomers? Well, let me give you an example. Let's try C2H6, C2H6O. Okay, C2H6O. Let me draw C2H6O like this. Here's C2, H5. I'll draw the hydroxyl functional group if you want the lone pairs. This is, of course, ethanol. Okay, this is ethanol. Is there another way to draw ethanol? The answer is no. This is the only way. However, you can put the oxygen in a different position relative to the carbon atoms. So if you sandwich the oxygen between 2 carbon, okay, and then you have the hydrogens at these positions, This is called an ether. Okay, so an ether basically is RO R prime, where the oxygen is sandwiched between two methyl branches or any kind of alkyl branches. So it could be methyl, ethyl, propyl, whatever it is. As long as you have the oxygen, which form a single bond with an alkyl group and a single bond with another alkyl group, and these two can actually be identical. So this could be, like here, it could be a methyl, so this is actually called dimethyl ether. And it's not going to look anything like ethanol. You see, ethanol is a liquid. Dimethyl ether is actually a gas at the same temperature. You can drink ethanol, but I wouldn't recommend that you breathe dimethyl ether. Well, anyway, so this is functional isomer. These are functional isomers because they have different functional groups. These two are totally different compounds, although they share the same chemical formula. And there are some other examples of functional isomerism, but I'm not going to go any further as long as you have a basic understanding of the difference between positional, functional, and structural isomers. I guess it's a lot easier for you to do a few exercises about structural isomers.